In this lesson, we are going to discuss about thiosulphate ion. There are two ways that the skeleton of thiosulphate ion can be drawn. This is a one-way method. In this method, all the oxygen atoms of the ion are bound to one sulfur atom. There's another way. In that one, one oxygen atom comes in the middle, and to that oxygen atom, two sulfur atoms are joined. But this is not going to be stable because this center oxygen atom has to keep two larger sulfur atoms and two oxygen atoms bound to that sulfur atom. So this is the correct one we use when we are going to draw the Lewis structure of thiosulphate. So now we count the number of total valence shell electrons that will be provided by each atom. There are 5 atoms. Each atom has 6 valence shell electrons. So then 6 into 5 and 2 negative charges will add up to 32 electrons. Then we will complete the octet of this out atom. And we used all the 32 electrons. So next step, we have to check whether the center sulfur atom has completed the octet. It has already completed, but sulfur can violate the octet rule, so it can take another 4 electrons. So we can get 2 from here and 2 from there, resulting this structure. Now I am going to number the atoms to determine the charges. 3, 4, 5. So each atom has 6 electrons in their valence shell, and when we consider the sulfur atom number 1, 2 plus 2, 4 plus 2, 6. And when it comes to here, 1, 1 is 2 plus 2, 4 plus 2, 6. And we come to here, 7 electron. And we come to the oxygen number 3, 7 electrons, and oxygen number 5 also has 7 electrons. When you come to 4, 6 electrons. So 0, 0, minus 1, 0, minus 1. So oxygen number 3 and 5 has negative charges. So in other words, when oxygen forms one sigma bond, it should bear a negative charge. Let us move into the oxidation number of thiosulphate ion. When we come to sulfur atom number 1, it is connected to another sulfur. So there is no electronegative difference or polarization in the sigma bond and phi bond. So we can tell it is the oxidation number is 0. So when we move into sulfur atom number 2, 3 oxygen atoms have joined to that. So oxygen is more electronegative than sulfur. So sulfur get positively charged with that polarization. So with the single bond, sulfur gain positive charge and double bond two positive charges. So altogether from these two sigma bonds plus 2 and this double bond another plus 2. So it will add up to plus 4. So oxidation number of sulfur 2 is plus 4. When we come to oxygen atom number 3 and 4, oxygen withdraws electron, so oxygen get extra negative charge. With this already has negative charge in each oxygen atom, oxidation number should be minus 2. They have same number because they have same electron configuration. When you come to oxygen atom number 5, it's a double bond. Through this double bond, oxygen withdraw extra 2 electrons, so it is again minus 2. This is the ground electron configuration of sulfur. So when we consider sulfur atom 1, we can directly use this because sulfur atom number 1 is neutral. So sulfur atom number 1 refers 3 hybridized orbitals because it has 2 lone pairs and 1 sigma bond. So we can write 1 from S and 2 from P. P2, these are the 2 lone pairs and 1 single electron. So this one is used to create the sigma bond and the remaining one is used to create the phi bond. So sulfur atom number 1 has sp2 hybridization. Now when we consider sulfur atom number 2, it has 4 sigma bonds and 2 phi bonds. So it requires 4 hybridized orbitals to make 4 sigma bonds. So but when we consider here, there are 2 lone pairs, and with lone pairs we cannot make the sigma bond. So to make sigma bond we have to have uncoupled electron. So we have to transfer these 2 electrons to other orbitals. So here sulfur, we can do that in sulfur because sulfur has 3d orbitals also. So there are 5 3d orbitals. So I am going to transfer this electron to here. So I am going to erase this and also this one to there. Now we can use this to make 4 sigma bonds, and these d electron will be used to make the 2 phi bonds. So sulfur atom number 2 has sp3 hybridization. So when we consider oxygen number 4 and 3, we cannot directly use this configuration because they are charged. They each has 1 negative charge. That means they have extra 1 electron each. So we have to add that electron, and then when we consider there are 3 lone pairs and 1 sigma bond. So we have to have 4 hybridized orbitals. So we can use 1 from S and 3 from P. So there are 3 lone pairs and 1 electron. So this one is used to make the sigma bond. So oxygen atom number 3 and 4 have same configuration. So I can write O3 and O4 both have sp3 hybridization. Now when we consider oxygen atom number 5, it is neutral, so we cannot use this configuration. So I am going to use ground electron configuration. So in ground electron there are 6 electrons. So here there are 2 lone pairs and 1 sigma bond. So we have to have 3 hybridized orbitals, 1 from S and 2 from P. So there are 2 lone pairs and 1 electron. The remaining electron is used to make the phi bond. So oxygen atom number 5 has sp2 configuration. Now we can consider the geometry of this molecule. The center sulfur atom has 4 VACPR pairs. Even though there are two double bonds, we consider them as single unit. So there are no lone pairs. So the geometry of this ion is going to be tetrahedral.